Hey there! In this video, we're diving into something super exciting, modeling 3 awesome examples of flat pack furniture. You know, furniture where every piece is crafted with laser or CNC cuts from materials like plywood or metal, and then they come together without any extra hassle. We're going to take it step by step, modeling each of the 3 designs in all their glory, from the main shapes to where the joints go, and even the screws themselves. You'll see exactly how this type of furniture is designed and simulated. If you're into industrial design, architecture, fabrication, or precise modeling, this video is just for you. So, as always, stick with me and let's build these 3 cool models together from start to finish. Hi everyone, I'm Hossein and welcome to my channel. In this video, we're going to model a few simple but super useful pieces of furniture together. Things like a small stool, a wall-mounted shelf, and a compact furniture. The models themselves are straightforward, but here's the catch. We're not just creating the overall shape. This time, we're going to include as many real-world construction details as possible. That means screw locations, holes, joints, and even the screws themselves. So the final result is a fully accurate model that's very close to how the actual furniture would be built. Before we jump into the hands-on part, let me quickly talk about the idea of flat pack furniture, because understanding it really helps with the modeling process. Flat pack furniture refers to pieces that are manufactured and packaged as separate flat components, which the user later assembles on site. This approach has several major advantages. It reduces shipping costs and hassle, makes packaging much more compact, and even allows you to customize or replace certain parts. Because of these benefits, flat pack designs are perfect for small spaces, modern homes, and large-scale production. These kinds of products are usually made using precise 2D cuts on materials like plywood, MDF, metal, or engineered plastics. Tools like laser cutters and CNC machines prepare the components with high accuracy, so when it's time to assemble, everything fits together like a perfect puzzle, often without the need for any complicated tools. This clever combination of 2D fabrication and 3D assembly is what makes flat pack furniture one of the most efficient and economical ways to produce functional designs. Alright, without further delay, let's get started. Alright, let's jump into the first exercise of this session. The model we're going to build is a Toddler Step Stool, a small children's stool that's designed and manufactured in a flat pack style. As the long-time viewers of the channel already know, there are 2 important principles we always keep in mind before starting any modeling process. Don't panic, and simplify the form in your mind. Fortunately, this model isn't intimidating at all. The overall shape is very straightforward, and especially for those of you who've already tackled much more complex challenges in previous videos, this one will be totally manageable. This model has 2 identical side members, plus a few inner pieces that make up the steps. So we'll begin with the sides. I start by using the polyline tool to trace the overall section of the side panel, exactly what you're seeing on the screen. Once the shape is drawn, I soften the corners with a small fillet to make it look a bit more realistic. At this stage, I also mark the screw holes because these little details make a big difference in the final quality of the model. When everything looks good, I use Extrude Curve to give the piece its thickness. Then I apply a very small fillet edge along the edges. So for example, if the panel is 1 centimeter thick, a fillet of about 1 millimeter is perfectly enough and looks natural. These subtle fillets have a huge impact on how realistic the model feels. Now that one side panel is ready, I hold Alt, drag the gumball, and create a copy, placing it on the opposite side, exactly as you see here. Now let's move on to the middle pieces. Just like before, I start by drawing the cross sections of the middle parts based on the reference image, and then I extrude them. The logic here is very straightforward. The length of these pieces should match the exact distance we established between the 2 side panels. With the help of OSnap, it's easy to pick the key points accurately and avoid any mistakes. Again, I add small fillets to the edges, so the model doesn't look overly sharp or artificial. Next, to create the screw hole locations on the middle pieces, I draw a small cylinder, position it slightly inside the geometry, and use Boolean difference to cut out the holes, just like you would see in a real manufactured product. I then finish the remaining details exactly as shown in the reference. Alright, now we get to the fun part, modeling the screws. First, I draw the screw profile to the specified dimensions, then use the Revolve command around the screw's central axis to create the main body. To make the screwdriver slot on the screw head, I model 2 small boxes perpendicular to each other to form a plus shape, then Boolean union them into a single piece. I position that piece on the screw head and use Boolean difference to subtract it, which creates the screwdriver slot. Next, it's time to model the threads. I draw a spiral and extract the 2 main contours from the screw surface. I offset the helix, rebuild the curves for smoothness, and loft between them to create the thread surface. Finally, I give that surface thickness using offset surface. At the end, I Boolean union all the screw parts so the screw becomes a single solid object. Now the screw is ready, I make several copies and place them carefully into their locations on the model. To make the model look cleaner and more presentable, I'll assign materials to the different parts. If you want to take your viewport appearance, material setup, or render settings to a more professional level, I've made a dedicated video on exactly that topic. The link is on the screen and also in the description below. And that wraps up the first exercise. If you're ready, let's move on to the next one. If you've found the video helpful so far, I'd really appreciate a quick like. And if you have any thoughts or questions, feel free to leave a comment. I always enjoy reading them and discussing things with you. If you're not subscribed yet, make sure to hit the subscribe button and turn on the notification bell so you won't miss the upcoming videos. And if you think this tutorial could help someone, feel free to share it with your friends or colleagues. Every bit of support helps the channel grow and allows me to create more and better content for you. Moving on to exercise 2, this time we're going to model a simple shelf or niche that, just like real flat pack examples, is made of a few flat pieces and assembled with screws. The workflow, in terms of logic and sequence, is exactly the same as the previous exercise. So I'll just quickly review the parts we already learned to save you some time, but the modeling process is exactly the same as what we did with the step stool. Just like in the previous exercise, we begin with the side pieces. As you can see on the screen, I use the polyline tool to draw the side. I round the edges with a fillet and also mark the screw holes. Exactly the same method we used in exercise 1, so I won't go into the repetitive details. Once the side shape is complete, I give it thickness using Extrude Curve. Finally, I apply a light fillet edge along the edges to take it out of the raw state and give it a more natural look. Then, as always, I hold Alt and move the gumball to create a copy of the side, placing it at the desired distance so the main shelf form starts to take shape. Now it's time for the inner pieces that make up the inside surfaces of the shelf. The process here is similar to the previous exercise. I draw the cross-section of each piece according to the reference image. I give it thickness using Extrude. I adjust the length of the piece based on the distance between the two side panels using O-snap to make sure it's accurate. Then I apply a fillet to the edges to take away the sharpness and give it a smoother, more natural form. I place each piece in its proper position, one by one, until the skeleton of the shelf is complete. Since we fully modelled the screws in the previous exercise, there's no need to recreate them here. We simply use the pre-made screws, I make copies of them, then, following the connection points on the side panels and inner pieces, I place them carefully in their correct positions. This step goes much faster because the connection structure is simpler than it was for the step stool. At the end, just like in the previous exercise, I apply appropriate materials to the shelf pieces to make the model look cleaner and more realistic. And that wraps up exercise 2 successfully. Moving on to exercise 3. This model, like the previous 2 exercises, is a flat pack furniture piece, and the overall workflow isn't fundamentally different. However, it has a few smaller, finer details that make the final result look more realistic. As always, we start with the side of the furniture. As you can see on the screen, I first draw the side's cross-section, then I give it the desired thickness with extrude. Next, I move on to the initial details, rounding the edges with fillet edge, fixing sharp corners, and marking areas that will later be used for connections. Once the first side is complete, just like in the previous exercises, I hold Alt and use the gumball to create a copy, placing it at the appropriate distance for the width of the furniture. Now we move on to the inner pieces, the parts that complete the main form of the furniture. The process is the same as before. I draw the cross-section of each piece, give it thickness using Extrude Curve, apply fillet to the edges, and finally adjust their orientation so they fit correctly between the 2 side panels. This step may require a bit more precise rotation or positioning, depending on the furniture design, but using O-snap and the gumball makes it very easy. At this stage, just like in the previous exercises, I use the pre-made screws that we modelled at the beginning of the video. All I need to do is make a few copies and place them very precisely at the connection points marked on the side panels and inner pieces. This not only makes the model look more realistic, but also gives the final render a more professional touch. At the end, I apply appropriate materials to all the furniture pieces to make the model look polished and ready for rendering or presentation. As I mentioned earlier, there's a separate video on the channel that covers viewport settings, lighting and materials in detail, and I've included the links in the video description. So far, we've built 3 popular flat pack models together, from the Toddler Step Stool to a simple shelf, and finally a compact sofa, each adding a new feature to our learning process. If you follow these 3 exercises carefully, you'll have learned a significant part of the flat pack furniture modeling workflow in Rhino. From now on, whatever design you see, whether it's a shelf, a table, or a chair, you'll be able to break it down piece by piece and create its 3D model. If you enjoyed this video, leaving a like and a comment really helps. And if there's a specific model you'd like us to build together, let me know in the comments. As always, I'll try to pick the best suggestions and cover them in future tutorials. Thanks for sticking with me until the end. I'm Hossein, and I hope you always stay inspired and creative. See you in the next video. Bye for now.